In last 24 hours, the globe has witnessed two major earthquakes, one off the coast of Japan and one right here in India in Manipur. Now when we are talking about both of these earthquakes, one led to tsunami and one led to major tremors across northeast of India. But they are very different in terms of the point of origin and how they are originating. Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh and in today's session we are going to talk about these two earthquakes, how they are different, how come one led to tsunami and other did not, and understand what goes behind it. So let us begin with the understanding that what exactly has happened. So the first earthquake that I am talking about is a 7.4 magnitude earthquake that has taken place in northern Japan. Now we are aware that Japan is one of the most seismically active countries. But when we are looking at another earthquake that I am talking about that has happened in our country only, in Manipur, the magnitude was 5.2, but at the same time the tremors were felt across northeast. Now the first earthquake of Japan that I was talking about, this has led to tsunami where we have seen waves up to 80 centimeter. But when we are talking about both of these, they have occurred within hours. First, we had the Japan earthquake, then the Manipur earthquake happened. So how they are different apart from time, let us try to understand that. Starting with Japan earthquake. Now when we are looking at Japan's earthquake, the reason lies in this very same fact that makes Japan one of the most seismically active countries across the world. So when we look at the location of Japan right here, we clearly get to see that it is at the convergence of four major plates, not one, not two, four major plates. First we have North American plate, then we have Pacific plate, then we have Eurasian plate, and then we have Philippine plate right here. Now when we are looking at this particular region itself, we can understand that there will be a lot of tectonic activity taking place. Let us try to understand how. So when we are talking about convergence of plates, one plate coming towards another, that is convergence. When there is one of them is oceanic and the other one is continental, subduction occurs. The oceanic plate goes beneath the continental plate. And when we are talking about this situation where one oceanic plate and one continental plate is converging, this leads to not just tectonic disturbances but also volcanism. So if you remember Mount Fuji, one of the most famous mountains of Japan, it is a volcanic mountain and the reason is this very subduction zone which is formed there. Apart from that, we also have to understand that Japan lies in Pacific Ring of Fire. This red marked area, this is Pacific Ring of Fire. Why are we calling it Pacific Ring of Fire? Because of the extreme volcanic activity that takes place in this region because of the subduction zones which are formed here. So one subduction zone leads to formation of this Japan Trench, Kuril Trench, Ryukyu Trench, Philippine Trench, and this is where we are seeing the volcanic activities happening. So one answer we got, volcanic activity understood. But what about earthquake? Now when we are talking about earthquake as well, it is the very same reason. In this earthquake as well, in this very earthquake too, we are getting that Pacific plate, which is an oceanic plate, was going beneath the North American plate, and the release of energy because of the movement, because of the friction, the release of energy led to the earthquake. Now this earthquake was comparatively a shallower one. The location was offshore from the Iwate prefecture which is located, and as I mentioned, the depth was limited, which is usually seen in subduction earthquakes. So now we have understood how there is convergence of multiple plates and also how there is formation of subduction zone right here which led to stress accumulation and sudden rupture which led to this earthquake. And that is why as an outcome we frequently see high magnitude earthquakes in Japan, and this leads to tsunami generation. So one question might come in your mind that, ma'am, how earthquake is leading to tsunami? So the answer is in the fact that when we are talking about shallow earthquakes, or specifically the undersea earthquakes, what happens because of the release of energy, because we have a stuck area in the rupture, the moment movement takes place, there is release of energy which leads to vertical displacement of water. Now, once we have one water column displaced, this energy will travel along as long waves, and as gradually this energy travels, the height of wave keeps increasing the more it comes closer to the coast. Now, gradually the height increase is so much, we get to see formation of these giant waves, which is tsunami. So, when we are talking about subduction zones where shallow earthquakes are common, and if these earthquakes are happening undersea, tsunami is something that is seen, and that is why subduction zones are the area where we have maximum tsunami risk globally. Now, when we are looking back at Pacific Ring of Fire, this is not just about volcanism but a lot of region which is formed, but a lot of convergence here leads to formation of subduction zone as well. So, it is not just volcanism, earthquakes, but also the risk of tsunami itself. And Japan, again, not just seismically active, vulnerable to volcanism, earthquakes, as well as tsunami in this very context. Now that we have talked about this earthquake, let us move to understand that what happened in Manipur. So, when we are talking about Manipur earthquake, we have to understand first the location. So, when we are talking about location of the state itself, Manipur itself is located in zone 5 when we are talking about the seismicity present across country. So, when we are looking at the seismic zone, we have 4 major zones: zone 2, zone 3, zone 4 and zone 5. Zone 2 is least active and zone 5 is the highest in terms of seismic activity. So, Manipur is located in zone 5. Now, this particular area, when we are talking about how we get to see seismic activity here, has 3 major regions, has 3 major factors here. First, we have Indian and Eurasian plate where we are seeing collision, which is responsible for the formation of Himalayas, and then also the Indo-Burma arc which is present, that is also responsible for the seismicity seen in this particular zone. Now, let us try to decipher what happened here. So, when we are looking at what exactly unfolded, we know that 5.2 magnitude earthquake happened. It occurred in Kamjong district. Now, the depth here is of main significance, which was 62 kilometers. That means deep inside earth, and the tremors were felt not just in this particular state but across northeast when we talk about. Now, when we are looking at this region, as I said, there are 3 big influences which are occurring here. How they are occurring, let's talk about that. So, when we are looking at first Indian plate, we have to understand that Indian plate is moving northwards, but when we are specifically looking into it, it is more of a northeast movement. Now, it is colliding with what? Eurasian plate. But apart from that, because the movement is towards northeast, we also have Burma plate, which is a micro plate where there is not just compression but at the same time sideway movement is also leading to a lot of tension. So, now this is where we are getting to see that Indian plate is colliding northwards in 2 ways. First, we have a direct collision zone with Eurasian plate. Second, we are seeing a lot of faulting in Indo-Burma arc. Indo-Burma arc is not a classic subduction zone that we seen based on textbook, but at the same time, there are some subduction like features that are seen. For example, if you go southwards from Indo-Burma arc, you see formation of Sunda trench. So, some subduction like activities are occurring. So, in this context, the movement of India plate towards northeast, we get to see crustal deformation and stress release, and this stress release was the reason of the earthquake. And that is why when we are talking about depth, I said it is significant. This is what led to wider felt area where the waves were felt, and second, lower surface destruction. It was because of the depth itself that the surface destruction was limited, because the movement of waves was so much in terms of this number that the surface destruction came out to be limited. Now when we are looking at this particular earthquake, it was not a shallow one, deep focus was present, and this is where we get to see this is not an undersea earthquake. That is why no tsunami is occurring. Had this have been happening in Sunda Trench or probably deeper southern in Indian Ocean, we could have had a tsunami like situation, the one which we saw in 2004 and other times when we are talking from the perspective of Pacific Ocean. Now this is where we can establish and understand that is why Northeast India comes in zone 5, because there is collision constantly occurring. So it's a collision zone which leads to frequent but moderate earthquakes in this very region itself. Now when we compare across, we clearly get to see the earthquake in Japan had the tectonic setting of subduction zone, but an earthquake in Manipur was responsible because of collision and the fault zone which is present. The plate interaction is different in both. Japan, we had oceanic plate and continental plate. In Manipur, we have continental plates both on the both end. Furthermore, the depth is different. Depth is shallow in the Japan earthquake, where it was limited. It was more deep when we are talking about the Manipur earthquake. Magnitude, highly different. Shallow earthquake, more effect in terms of waves and in terms of destruction. Moderate frequency, we get to see here. Secondary hazards were limited in Manipur earthquake. However, it was tsunami which came out as secondary hazard in Japan earthquake. And when we talk about seismic belt, we have Pacific Ring of Fire for Japan and Alpine Himalayan belt which is for Manipur. I hope we have a fair clarity that what happened in both of the earthquakes, that what exactly was different. If you have any doubts, you can let me know in the comment section. That was all from my side. I'll be leaving you here with a prelims practice question. Let me know the answer in the comment section. That was all. Thank you so much.